quickly you can sort of introduce yourself, your topic, and then 10-12 minutes is yours.
Yes, I can see the slide. You can make it bigger if you want, or if you are comfortable with this, fine also. It looks good. No problem.
Sorry, I was muted. Good evening, everyone. I'll make it full screen. Yeah. So good evening, everyone, and thanks for inviting me to speak among all of you. You are all experts here, and what I'm going to present here is going to be very short presentation regarding the most pressing problem in Maharashtra. Onion, a lot of farmers in Maharashtra and elsewhere also, you will see that they are struggling with the when it comes to pricing of onion, there is so much volatility involved in that. So somehow we just got into this problem, and a couple of MTech students looked at this problem very carefully from the point of view of value chain analysis, and realized that there are a couple of things that needs very serious technological intervention to take care of most of the issues that are involved in onion value chain. So I'm going to present that in next 10 minutes. Will be very, very brief, but I'll be open to questions later on. Thank you. Regarding my introduction, I think Professor Shah has already mentioned. My training is in agriculture engineering. Graduated from IIT Kharagpur back in 2005. Went to US, University of Illinois, Urbana-Champaign. Did my PhD there in mostly in food and bioprocess engineering in bioenergy and biofuels area. Worked as assistant professor at University of Wisconsin for a couple of years before coming back to India. So that's in short. Okay, so here, so my topic says it's a climate agnostic onion storage structure. And let me put a context to it. So if you look at, today's situation for farmers, onion growing farmers, you will see that there are more than 30 to 50% losses in the value chain itself. Because that does not happen only on the farm, but across the value chain, losses are very, very significant. And we all are very well aware that how onion prices volatility is so very significant. Onion can be bought at 5 rupees per kg in a given season. And the other side of the spectrum is one may have to shell out 120 rupees to get 1 kg of onion. So that's the reality. But this money doesn't really go to farmers' hand, as we all are aware of that. So that was the context given to us after doing a couple of years of value chain analysis in this area. So what we realized is, so there were certain issues when it comes to storage of these onions. So this was a part of our study my couple of MTech students did. They realized that, so there are 2 seasons essentially when onion harvesting happens. One is Rabi and another is Kharif. So Rabi season is essentially harvested in March and April, and stored till almost till Diwali. So for 6 months, one need to store it, and then you will get Kharif onion. The harvest of Kharif onion comes out after Diwali or near Diwali. So how do you store these onions for 6 months? That has been a challenge. And why this has been a challenge? I think this is an agriculture community, so you understand that there are both pre-harvest and post-harvest factors, that contributes to that. And I don't get into details, but important part here for me to point out is, if you look at right-hand side post-harvest factors, we have curing and storage conditions. So these two actually contribute very, very significantly in deciding the shelf life of this produce. So why curing and why storage? These two things I have mentioned. If there is a negligence on curing side, basically when you pull out the onion from during harvest, you leave it in a field so that it gets dried naturally in sun drying, and then you will go for storage. It's a ventilated storage structure system. So what is reported in last few years, this is data coming from Directorate of Onion and Garlic Research, Pune. So about 35 to 40% losses have been reported in this area. So of course, there is a solution to that. You can do artificial, artificially you can cure it in a drying system. You can have an artificial dryer where you can do this, and you can get rid of these problems like black mold, bacterial brown rot, and all things like that. Now, why field curing is not good? There are several reasons. You can clearly see you cannot control temperature and relative humidity, just like Professor Shah mentioned in his previous presentation. There is no way we can control these variations in temperatures. So especially diurnal changes are very, very huge. Field is occupied for more than 2 weeks, and look at this graph that clearly shows this is a field visit data that we had. For same day, you will realize that how much variation is there in temperature. Okay, it's very, very, very significant. And this is the field data that you see here. So what we thought, let us, rather than, okay, sorry, I think I have missed one slide. Anyway, so rather than having this, all sorts of variables controlling us, let us control those variables and be able to see whether we can manage to improve the shelf life of onions. So here comes the idea of developing a climate agnostic storage structure where we can control these parameters like temperature, relative humidity, and other physiological weight loss parameters and things like that, so that we can give right environment for onion to thrive. And so sprouting and rotting losses can be minimized. So we developed this tier system, which you can see on the right hand side of the picture. And this was done at IIT Bombay. We also have a signed MOU with DOGR. So we worked together and developed this. So if you really looked at what we did is we designed and developed the system, then we did performance evaluation, and then we also did techno-economic analysis of that. So this is typically what you see in India, whether it's Maharashtra or UP or MP, wherever you go, you will see this on the left-hand side. These are the traditional storage structures which are plentifully available. Unfortunately, they don't do the trick because it's all open to the environment and you can't control temperature and relative humidity. In a state like MP, it's still okay because you don't get rains like Maharashtra, Mumbai, or Konkan area where you have more relative humidity. Wherever there's a dry region, you can still able to manage it. And the concept that Professor Shah was talking about, evaporative cooling, that may do the trick. But in other regions which are more susceptible, where you have high relative humidity and temperature, then it becomes much more difficult to handle. And that's the reason we thought of doing some experiments. So these are just some, our initial days back in 2016, 2017, when we started this project. We dismantled one fridge to see whether we can develop something very small. Then we actually, installed one full system in DOGR itself. The system is still there. If you can go there. There were many challenges when we were doing this, because challenge of maintaining not just temperature and relative humidity, but also making sure that you get good amount of fresh air pass in the system, because onion is known for releasing these gases that are troublesome. And so a lot of engineering was involved. We did CFD analysis and figured out what is the best orientation, what is the best flow rate, how much air should be passed through each tier of the system. So we developed this CFD analysis. This is the storage structure that we came up with. Of course, you can see here, maintaining RH is very important. Sometimes you see that relative humidity is not enough, and that basically reduces the overall weight of onion. So farmers will lose on the price. So I think maintaining RH was also very, very important. So we followed some experimental designs. For want of time, I won't get into that. Just to explain you. So you see there are two words, AC and C, and then AS and NS. AC is artificial curing. NS is normal storage or natural storage. And AS is artificial storage. And NS is, AC is your artificial curing. So we took this essentially permutation combination, natural versus artificial environment. And we did this trial with all, with all experimental design. These are the lab pictures. We did, we did this controlled study with proper sampling and everything. So these are just snapshots, just to show that we actually did this properly. And what we got was very, very exciting. If you look at the final results, which is shown in this slide, so the rightmost, natural curing plus natural storage, which is the conventional method of doing, you see the sprouting losses are more than 20%. When we compared this with the best environment that we had, artificial curing plus artificial storage, losses were about 5%. So clearly the 20%, you see the losses that are happening because of this, that can be cured very well. using this AC plus AS condition. So that was our finding. This is about sprouting side. About rotting losses, we did this study for last, I think this was the third year when we were running this. So we are able to save about 15%, 15 to 20% of onion there compared to traditional structure. That's again very, very significant. So if I want to sum it up, what can be done is instead of using a traditional storage structure, if you shift from that to climate agnostic, very well controlled environment structure, then this huge amount of savings can be realized. Having said that, I should also mention that this will make sense only when we are targeting at least 100 tons of storage structure, because otherwise economics doesn't fit very well. Okay, so that is one of the outcomes in our techno-economic analysis. For want of time, I would not show that. So let me just close it here. One more thing I would like to mention here is, so we have successfully demonstrated 3 tons and 20 tons also with DOGR. Now we are working with the Parbhani Agriculture, VNMKV Parbhani, to set up 100-ton unit. And we are also working with the Pokhara government of Maharashtra project on climate resilient agriculture with the project director there. It's a World Bank funded project. So we are targeting 500 tons to 1,000 tons of storage structures in different parts of dry land areas in Maharashtra. So this is an ongoing work. I mean, we didn't realize that an MTech project can go this far, so we are happy about that. So I'll be happy to take questions. Just one quick slide I'll show. We were also doing something related to, I think Professor Kaviare will talk about that. How can we also empower our farmers to design and develop a forewarnings model or system for onion storage losses? So suppose onions are going to spoil in next 3 days, they should get an alert that, this is the right time when you should sell it off or make some better use of it. Otherwise, it's going to cost you much. So this was a work in progress. Because of COVID, we had to stop it. So we did some basic work here. And hopefully, after this lockdown and all, we will continue to do that. Okay, I'll stop here. Thank you.
Thank you, Dr. Amit. It's a very interesting topic, and it's a topic of the need of the day. Because I know as a travel